And so we're doing the derivation of the cosine of the difference of two angles. We start off with two circles, both of them unit circles. For the first circle we'll have two angles. We'll have an angle alpha and we'll have an angle beta. And then the difference of those two angles is given by beta minus alpha. The intersection of the ray for the terminal side of alpha with the unit circle, we'll label those coordinates as x sub 1 and y sub 1. For the ray for the terminal side of beta with the intersection of the unit circle, we'll label those coordinates as x sub 2 and y sub 2. For the second circle, we'll have one angle, beta minus alpha, which will assume that the intersection of the terminal side of beta minus alpha with the unit circle has coordinates x3 and y3. For the triangle in the first circle, we'll notice that because that angle is beta minus alpha, the distance between x sub 1 and y sub 1 and x sub 2 and y sub 2 should be the same as the distance from 1, 0 to the point x sub 3 and y sub 3 on the second unit circle. And that's going to be important. And since the distance between those will be the same, means we can write down an equation. So using the distance formula, plugging those points in, we have the square root of x sub 1 minus x sub 2 squared plus y sub 1 minus y sub 2 squared gives me the square root of x sub 3 minus 1 squared plus y sub 3 minus 0 squared. If we square both sides, we get rid of the square roots, and then we expand the squared terms so that we have x sub 1 squared minus 2 x sub 1 x sub 2 plus x sub 2 squared. We have y sub 1 squared minus 2 y sub 1 y sub 2 plus y sub 2 squared. And then on the right hand side we have x sub 3 squared minus 2 x sub 3 plus 1 plus y squared. So if we regroup and put the x sub 1 squared and the y sub 1 squared together, the x sub 2 squared and the y sub 2 squared together, and then all the other remaining terms on the left. Then on the right, we'll put the x sub 3 squared and the y sub 3 squared together, and the remaining terms over on the right. Now we remember that the equation for the unit circle centered at the origin is given by x squared plus y squared is equal to 1. Now we made the assumption in our drawing that x sub 1, y sub 1, x sub 2, y sub 2, and x sub 3, y sub 3 are points from the unit circle. And so that means they satisfy the equation for the unit circle. So this gives us x sub 1 squared plus y sub 1 squared is 1. X sub 2 squared plus y sub 2 squared is 1. And x sub 3 squared plus y sub 3 squared is 1. If we take those expressions and plug them into the equation that we just had, we see that our first grouping of x sub 1 squared plus y sub 1 squared goes to 1. X sub 2 squared plus y sub 2 squared gives us 1. And x sub 3 squared plus y sub 3 squared gives us 1. If we replace those with 1, collect terms, then we've got a 2 on each side. We can cancel the 2's. We can then cancel the coefficient of negative 2 in each one, and end up with an equation of x sub 3 is equal to x sub 1 times x sub 2 plus y sub 1 times y sub 2. Now since we're on the unit circle, remember that the x values are actually the cosine of the angle and the y values are actually the sine of the angle. And so coming back to the diagram that we started with, this means that x sub 2 is going to be the cosine of beta, y sub 2 is for the sine of beta, x sub 1 for the cosine of alpha, and y sub 1 for the sine of alpha. X sub 3 is the cosine of beta minus alpha, and y sub 3 is going to be the sine of beta minus alpha. If we plug those in to our expression, then we find that then we obtain our trig identity of the cosine of beta minus alpha is the cosine of alpha times the cosine of beta plus sine of alpha times sine of beta.